All right, we're going to get started with review exercise number 25. So if you would take out your speed drill and review exercise booklet, turn to page 22. And remember last time we talked about health insurance, right? And the idea of health insurance is you have some sort of health needs that need to be taken care of, and you don't have the money to pay it. That's where health insurance comes in. The person who has health insurance is often referred to as the policyholder. And they have to make payments to the insurance company. Payments called? Payments to the insurance company. Any insurance payment in general is called a premium. Premium. So remember, the premium is what you pay to the insurance company. And when they have some sort of health-related expense, especially a major health-related expense, there will be a specific amount that they just have to pay right up front. That's the deductible. And then for many procedures, in addition to the deductible, the insurance company won't cover everything. They're going to cover a percentage. And that percentage that the policyholder has to pay, we call the copayment. Now, I will say lately I've noticed more and more companies are phasing out the copay, and they're just making a deductible right up front. Okay, you go to the emergency room, you're going to pay $150, we'll cover the rest. You're going to go to the hospital for any sort of procedure where you stay in the hospital, it's going to be $1,000 that day, we're going to cover the rest, kind of thing. So it's more of an upfront type of deductible based on thing or a dollar figure copay, but there are still some policies that have the deductible and percentage copay. And most health insurance policies nowadays have a specific number at which, okay, if you hit this amount of money that you've had to pay through deductibles and copayments, once you hit this number, we'll cover everything after this for you. And that's the out-of-pocket maximum. Okay, the annual out-of-pocket maximum. And once you paid this much, most health plans it's around $12,000. But once you've paid this much, we're going to cover everything else. An individual policy, which is what I have just for me, once you hit $6,000 is a pretty common number. Okay, we're going to cover everything after that. And so out-of-pocket maximum is an important number, especially if you've got a lot of different health issues to look at. Obviously, the better your insurance, the lower the co-pays, the lower the deductibles, the lower the out-of-pocket max, the higher the premiums, because they'll charge you more every month for the policy if their coverage is going to have to be better. So if you're a healthy person, you don't get hurt much, you don't get sick much, maybe you want to pay a lower premium. Well, if you did have an issue, you'd have a higher payment on the tail end. Questions on that? All right, so I have 4 problems for you, all dealing with somebody named Jillian. So exercise 25, go ahead and get started. course, all these problems do build on each other. So when you get down to the last problem, it's going to use answers from previous problems, or things that you solved in previous problems. Just a little bit longer to be finishing up. All right, for sake of time, let's go ahead and take a look at these and able to finish. Okay.
I don't know if I hit it right.
All right, well, let's take a look here. Jillian has a health insurance policy with a monthly premium, that's an important word, monthly, premium of $57.30. This past year, she got an annual physical, which would have cost $573.98, but was covered 100% by her policy. If she had no other medical treatments or care this year, how much money did she lose by paying for health insurance? You realize she paid more for health insurance than she would have for just paying for the physical. Does that make sense? So the first thing you had to do is figure out how much did she pay for her health insurance, right? How would you do that?
57 times 12.
Right, and when you multiply that by 12, should have gotten?
$687.60.
Good, so this is how much she paid for insurance. And she would have only had to pay, if she decided, well, nowadays it's a crime apparently not to have health insurance, but if she decided, I don't want health insurance, I don't need health insurance, how much would she have paid? $573.98, right? That's how much the care would have cost her. It would have been cheaper just to pay for the care, right? In fact, in a lot of cases, people who don't have insurance, if they appeal to the doctor will lower the bill for them to try to help them out a little bit. But even if she didn't do that, she would have saved money by just not having health insurance this particular year. How much did she lose? Anyone?
$113.62.
Good, so this is how much she lost by paying for health insurance. All right, this is year number 1. She took a loss by having health insurance. But how does she know she wasn't going to have something come up? And this is why people pay for insurance, is the what if. Does that make sense now, Josh? She spent more on insurance than she would have for care, so she literally lost money by having. But, next problem. Jillian doesn't know it yet, but she's going to hurt her back this year, and she's going to have to begin having chiropractic treatments. Each treatment is $160, but she has only a 20% copay. So how much will Jillian have to pay for each chiropractic treatment? All right, it does not mention a deductible, so we're only worried about the copay here. How much would she have to pay if she's paying 20%? Class? $32. So each chiro treatment costs her $32. This is Jillian, which means how much does the insurance company pay for each treatment? This isn't asked here, but we would have had to find it here in just a minute. So $160 treatment, right? 32 Jillian, how much does insurance pay on each treatment? We would have had to find this to do the next problem anyway. 128. Right, she pays 32, insurance pays 128, right? All right, that brings us to the next problem. If Jillian gets 2 treatments a month for 5 months, how much will the insurance company pay for her chiropractic care? Well, keep in mind, the insurance company's paying $128 each treatment, right? 2 treatments each month for 5 months. How many treatments is that? Okay, for 5 months, folks, she goes in twice a month. How many treatments? 10, thank you. You didn't say 10. You said, huh? You said 10, right? Every treatment, insurance is paying this much. So how much does insurance pay for her 10 treatments? Not Jillian, insurance. How much does insurance pay for those 10 treatments? $1,280. Okay, your voice says, Mr. Jasky, I said that already. No, you didn't. All right, does it make sense? Insurance just paid out $1,280 for those 10 treatments. All right, now, assuming, next problem, Jillian's premiums remain $57.30 each month, and she receives no other medical care this year, how much will she save by paying for health insurance this year? Well, this is how much she saved up front, right? But remember, how much is she paying every year for her insurance?
$687.60.
So this is how much she saved minus, she did pay $687.60. So what were her real savings this year? When you subtract, you should get $592.40. So this year she saves $592.40. When you subtract?
You borrow from the 7 and then 10 minus 7 is 30.
You have to borrow again to do 10 minus 6 is 4. So 9 minus 7, 2, 17 minus 8 is 9. So she ends up saving, these are her true savings, right? She didn't really save $1,280 because she paid so much to the insurance company. Now let me ask you, this isn't one of the questions, but in those 2 years put together, remember the first year she lost money, right? She would have been better off without insurance. Second year, man, I'm thankful I had insurance. In the long run, is she doing good or is she doing bad having insurance? Good. She's doing good because she saved more the second year than she lost the first year. So yeah, in the end, probably a good idea to have the health insurance. Questions on exercise 25. I know we didn't get them on our own, but now that we've gone over them, does it make sense how to think these sorts of things through?
You got the first two.
Okay, so you got the first two. Here's the key, was recognizing this number. Because this is the only way to solve the next problem, right? The next problem said, how much did the insurance company pay? We first had to figure out the 128 per treatment times the 10 treatments to figure out how much the insurance company was paying. And of course, had to get that number then to get the final number.
Wait, the answer to number 2 was $32?
Right, 32, because that's how much it asked, how much did Jillian pay? That was the answer to number 2. How much did Jillian pay? Jillian paid 32. But then the next problem used the 80%, if you will, the $128 that insurance was paying out, which was never asked. You had to figure it out and then use it. Does that make sense? I never asked how much did insurance pay per treatment, but you couldn't possibly solve the next problem if you didn't figure that out first. Make sense? For instance, okay, let me give you an example here. Okay, sorry to blow your brain here. In pre-calculus, I asked a student of mine, what is the slope of the altitude to the longest side of a triangle? I never asked, what's the longest side? But he had to find it. He had to figure out which was the longest side, or else he couldn't solve the problem. And what's the slope of the altitude? Well, you have to figure out what the slope of the side is first. I didn't say find the slope of the other side. He had to know, I can't possibly solve this until I first solve this, 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 and this. So there were 4 things I never asked for, but if he didn't solve them, he couldn't possibly solve that. This was that kind of problem. It's a deeper level thinking problem of, I know he never asked for this, but he kind of did. He kind of did ask for the 128 insurance. It wasn't one of the answers I write down, but I had to figure it out to get the next thing. All right, so deeper level of thinking, trying to get you to think a little bit deeper and think about real life practical stuff too. All right, let me go and collect those from you. Take out your textbooks, turn to page 415. Take out your textbooks, turn to page 415. And on page 415, I want you to do numbers 29 and 30. Page 415, do numbers 29 and 30. Page 415. Numbers 29 and 30. And Scott, not to exclude you, if you have questions or things like that on practice exercises, or if you just want to gloat and say, hey, I got them all, you can certainly feel free to have them on email me. I'd be thrilled to hear how things are going, or to be able to help you out. If you have questions that are not answered on video, that applies to all things, not just review exercises. So let me know if you ever have questions. But for now, you're doing page 415, numbers 29 and 30. let's see how we did on these. And take a look at that first set of data, that first set of statistics. What do we get for the mean, Lana?
28.6.
Good. When you round, 28.6. What about for the? I'm sorry.
I did 28.47. Is that the same?
It is, but it said round to the 10th. So we do that first division. It's 28.57, I think, and then the 7 would bump it up to a 6, so 28.6. What about for the median, Joshua?
33.
33, and then what about the mode, Lana? 15. Now, interestingly here, which of those three numbers is obviously a horrible measure of center?
43. Oh no. 15 and
15 for sure.
Yeah.
It's the mode, but those numbers are a lot lower. Like there's 2 of them, but all the other numbers are way bigger, right? It's the smallest number on the list. It just happens to appear twice, right? So clearly the mode is not a good measure of center here, partly because it's such a small bunch, right? Yeah, that's also an outlier in a sense. So I would say probably the mean isn't the greatest here. I go with the median here, probably the best measure of center. How about number 30? What's the mean here, Joshua?
4 and 3/5, which is
Four should have been 4 7/10 or 4.7. So I think when you added it up, you got 46. Should have gotten 47 when you added it.
Oh.
Yeah, 47. So 4.7 would have been your answer. What about the median? Let's come right back to you.
4.5.
4.5, and the mode class.
Bimodal.
Yeah, you could almost argue bimodal, I suppose.
When there's 2, do you say no mode or bimodal?
4 and 8 are both modes in a sense. Again, it's such a small data set. I'd almost be inclined to say no mode, but I can see where you come up with bimodal, to be honest there. But again, by mode, I mean, there's only 1 more than everything else, 2 more, I don't know. I mean, if you're looking at a dot plot, right, it's like, and is there really a number that stands out? No, and I will say this, Lana. If it were like this, I would say bimodal, right? I mean, there's 2 that really separated themselves from everybody. Here, not much. Maybe this even. I'd say, okay, there's a mode. There's 1 number that's definitely more than the rest, but when it's just, they're each just 1 more than everything, I'd be inclined to say no mode, but I can see why you would say bimodal. And again, this in general, what branch of math are we studying here? Studying data?
Wait.
What branch of math studies data? Statistics, right? Is that branch of math that studies data? Mean, of course, means class. Average, median,
Middle.
and mode
Most.
most often. And what do we call that little sketchy thing, that little graph thing we just drew? Dot plot, right? Go and clear your desk, except for a sheet of paper and a pencil. Sheet of paper and a pencil, everything else away. Scott, if you'd ask your mom to give you quiz 30. Quiz 30. You just need a paper and pencil out. All right, when you get your quiz, put your first and last name in the name spot and today's date in the date spot. Today is 2/26/21. 2/26/21 today's date. If it makes you feel better, I'm not going to give you another quiz until next month. So I'm going to give you the rest of the month off after this. 2/26/21 today's date. Lana does not seem impressed by that joke at all. All right. 2/26/21. Yeah, Monday starts the next month. So anyway, 2/26/21 today's date. All right, pretty straightforward. Answer some questions and solve for some things as well. Put a little thought into those questions at the bottom as well. don't overthink it. Those are like word for word definitions. You know those. Come back to them later if you need to. Yeah, just move on. You'll happen upon them. You'll think of them as you go. Just move on. Don't waste time.
For the pictures, do I need to pack up?
You're coming back over, so no, just go down to the auditorium because that way you're not lugging a bunch of stuff with you.
Oh, we're taking it out for it?
I'm sorry, not auditorium.
The gymnasium.
Gymnasium, yeah. Maybe about 1 more minute to be finishing up. cross it out. Cross it out and write. All right, go and take out your homework if you would, please, and turn in your textbooks to page 412. Homework out and textbooks open to page 412. Page 412. Talked yesterday about this idea of probability that we've been looking at was based on random chance. Purely random, no skill, no conscious choice, anything like that ability. We called this theoretical probability. But in reality, in many cases, choices are not unconscious or subconscious, but rather made based off of a legitimate choice. You might not choose to play hockey given the choice. You might rather play baseball. Okay? Or if you lived up north, maybe you'd rather play hockey. You know, you might have a conscious choice. So it's not necessarily randomly choosing this or that. And we call that experimental probability. Based on past history in some cases, we talked about the probability of Glenn getting a hit in a baseball game versus a teammate of his possibly getting a hit. And we said, well, there's a better chance perhaps of some teammates than Glenn, maybe Glenn than other teammates. So we were picking on Glenn, said he was the worst hitter on the team. So relative frequency, things of that nature we looked at yesterday. Question number 1, what is probability based on what is observed? Joshua? Experimental. I observed that 70% of the time Joshua gets up to bat, he gets a hit. Okay, there's a 70% probability of him getting a hit. Not 50-50, but 70% of the time is what it happens. What about probability based on what's expected, Lana? Theoretical, based on, and I would say random chance as well. Table that shows the number of times each event occurs, Joshua.
Relative frequency table.
The other one, just frequency table. Shows how frequently something happens. And the table that shows the probability of each event occurring, that's the relative frequency table. So for instance, Joshua, number 5 and 6 in your textbook, those are frequency tables. They tell you how many people said baseball is my favorite sport, basketball, soccer, or maybe came up with something else. What they wanted us to create was a relative frequency table, showing the chances, the odds, as a decimal rather than a percent. So what are the odds somebody chooses baseball, if I can spell? What are the odds that someone chooses basketball? What are the odds that someone chooses soccer? I can't spell. Soccer. And what are the odds that somebody chooses something else? But here's the key. For relative frequencies, since relative frequency is a form of probability, what does the total have to be, class? 1. The total probability must end up at 1. So for instance, baseball, if 36 out of 150 people said baseball is my favorite sport, then what's the probability that someone's favorite sport is baseball in that group?
0.24.
0.24 when you divide, or 24% chance. What about the probability of basketball?
0.15.
Rounds to 0.15, not evenly, but it rounds there. What about soccer?
0.30.
Comes evenly to 0.3, or I don't mind 0.30. It keeps the 2 decimal places going. And then other 0.31. So 31% chance that someone had some other sport as their favorite if you were to ask one of those 150 people. Questions on that? Again, if there were 4 things to choose from, picked a person at random, you might say there's a 1 in 4 chance they would say soccer. But based on the people we polled, there's a 3 in 10 chance, right? 30% chance that they would pick soccer. What about people who ate lunch different ways? Some people went to the cafeteria. Some brought food that they had made at home, like in a paper bag or lunchbox. Some people went and get fast food. And then some people, maybe they go out to a fancy restaurant because they're bigwigs. This is probably like people who work, for instance, at, I don't know, like let's say St. Francis Hospital, for instance. Okay, there's a cafeteria there they could eat at. They could bring their food with them. They could go run across the street and get fast food, or maybe they take a longer lunch break. Anyway, what are the chances that if you ask a random person who works at this place, one of those 300 people, what are the odds that they eat at the cafeteria?
0.40.
Good. 0.4 or 0.40, 40% chance. What about the chance that they bring their lunch with them?
0.22.
Okay, good. A 22% chance. What about the odds that they go and get fast food from across the street?
0.28.
0.28, and something else is
0.1.
0.1 or 0.10, 10% chance. Again, the total of relative frequencies has to add up to, because relative frequency is simply probability. Look at the next page, number 7 through 11, all dealt off of this relative frequency table. Though I kind of lean toward this isn't relative frequency, because there's a word it keeps saying in number 8, number 9, number 10. It keeps saying randomly, which means it's not really so much relative frequency here. This is actually more a true probability, but whatever. These are different questions that are selected. So you first set up the frequency table. Science has 30 questions. Math has 50 questions. History has 40 questions. And English has 40 questions. The first thing you had to do was figure out how many total questions are in this test. 160 questions, all right? So, what's the probability of randomly choosing a question about math? Well, we need to set up our relative frequency table now. So science, math, I'm going to abbreviate history, and English. Again, total probabilities have to add up to 1. If 30 out of 160 questions are science, what's that probability, class?
0.11.
All right, what about math? 50 out of 160.
0.31.
40 out of 160.
0.25.
And another 40 out of 160, of course, is going to be another 0.25, and that does add up to 1. So, what's the probability of randomly choosing a question about math from this pool of questions?
Wait, what?
What's the probability, number 8? We already answered number 1, or number 7, which is 160. Yeah. Number 8, what's the probability of randomly choosing a question about math?
31%.
Good, 5 to 16 or 0.31.
I thought 31%.
31% would be correct as well. You could represent any of those. 5 to 16, I would accept. 0.31 is easy because it's on a relative frequency table we made, or 31% is what that means. What's the probability of choosing a question not? There's a complementary probability, right? Not about English. 75, because English is only 25% chance, so not English would be 75% chance. 3 to 4 would be correct as well. What's the probability of randomly choosing a question about history or science?
716.
Okay, I see where you got that. Not 7 to 16. Not, wait, see, no, I'm sorry. You're right, 7 to 16 is right. I thought my brain said not history science. Yeah, history science could be 7 to 16, or Lana, you said?
70%. I don't know how I got that.
Yeah, history science, when you add them together, 0.44, 44%. 44% chance you would get either science or history. Or, like you say, 7 to 16 would work as well. And were these probabilities experimental or theoretical?
Theoretical.
I would say theoretical, because it's randomly choosing, right? Now, I suppose we would say this. Let's say that students got to pick what kinds of questions they wanted. Okay, that would change things, right? But this is just randomly choosing. It's more theoretical probability. Number 12. Jude is an architect, uses polygons in his designs, number of sides for each of the polygons in one of his buildings. It's a really strange problem, but whatever. 3, 7, 6, 10, a lot of numbers. What is the mean, Joshua?
6.3.
Rounded 6.3. What about the
6.2.
6.2, eh?
It was like, I got 6.18 for line dividing.
What did you get when you added them all together? What did you get in the sum? Do you have the sum written down anywhere?
I can't find it.
Okay. Anyway, should have divided out to, I think it's 6.262626 if I'm not mistaken. And it should have rounded to 6.3. What did you get for the median, Lana?
6.
And the mode, Joshua?
No mode.
I would definitely say no mode here. I mean, there's 2 3s, 2 4s, 2 6s, 2 10s. I mean, the only one that's not a mode would be a 7. Okay, there's definitely no real mode here. No number stands out from this data set. Questions on the stuff that you learned. All right, now I want to take the last 5 minutes here just to show you a little bit about what would have been going on in 13 through 16. We're not going to test you on this. It's not, not something you have to know, but it's the kind of thing you'll see, for instance, on achievement testing, is can you figure out what a table is saying? Notice how I worded it. Can you figure out what a table is saying? Look at the table. It's talking about housing. Some people rent houses. Some people own houses. Some people are single. Some people married. How many, I'm going to ask you a question that's not on here. How many total people were interviewed?
500.
500. Do you see that 500 represents the total people that were interviewed? Now, how many total single people, class?
230.
How many total married people?
270.
270. How many total people rent?
240.
240. How many total people own? 260. Okay, so we understand the totals. Now, how many single people rent?
150.
150. How many single people own?
80.
80. Right? How many married people rent?
90.
How many married people own?
180.
180. Again, this is from the sample size of 500. Okay, so we understand how to read the table then, right? It's very common sense. So when it says number 13, how many single people own a house, we already said that. The answer is 80. And when it says how many married people were surveyed, obviously the answer is 270. We already answered both of those. Now here's where it gets fun. What is the probability of randomly choosing a person who is single? How many single people are there in the survey? 230. Out of how many total? 500. So what's the probability of getting a single person? 46%. Outstanding. 46 to 100. 230 out of 500. I knocked off the zeros. And then multiply by 2 to get 100. 46 over 100. Or you could divide. 230 divided by 500. But you figure, okay, how many people total fall into that category? How many total people overall? And just divide. Good job. All right, number 16. What's the probability of randomly choosing a person to survey who is married and rents? Okay, how many married renters? 90. Out of how many total?
500.
500.
Yeah.
So what's the probability of a married renter?
9
to 50, which is
180 to 100.
18 to 100.
Oh,
Right? Not to
18.
0. 18 to 100. In other words, 18%.
I accidentally put 90 over 270.
Okay, yeah, that would be how many of the, now if it had said this, Lana, what was the probability of a married person renting? That would be 90 to 270 because we're only looking at married people, right? How many of the married people will rent? 90 out of 270. What's the probability of randomly selecting a married renter? That's 90 to 500. Do you see the difference? Okay? But yeah, that's the kinds of things you'll see on standardized testing. So I wanted you to see it and at least put some thought into it. Not really that hard to understand, I don't think. Okay, does that make sense? All right, homework for this evening. Homework for this evening is to do page 417. Page 417. Do numbers 1 through 9. Numbers 1 through 9. Also on page 414, do numbers 1 through 11. Also on page 414, do numbers 1 through 11. So page 417, numbers 1 through 9, and page 414, numbers 1 through 11. We have our test coming up on Tuesday in lesson 128. That will cover all of chapter 8 except that last section on those two-way frequency tables, the one we just looked at. We're not going to get into all of that just for sake of time. Certainly an interesting read if you want to read on it, but we're not going to spend time covering it, and it won't be tested. All right, have a wonderful rest of your day and a wonderful weekend. When the bell rings, you'll be dismissed.